Recording in progress.
welcome you to SCI33205 and this is for M604, right? We arrived at the fourth chapter. All right. Yeah.
ประภวิทย์อยู่ที่YouTube นะครับ
YouTube นะครับ
is there okay hope that in only two people have something more so have many words improve something to zero this oneผมเพิ่งอะไรครับปรับปรุงไฟล์นะครับใช้อันล่าสุดกว่า 604
Okay.
Okay.
Yeah,
Here we start. Let's start. Let's there. Let me capture stuff. Okay. This one on. เครื่องนั้นที่ YouTube อีกอันหนึ่งไม่มีเอาไว้yeah I hope the sound nice to more most of you right yeah it's okay I hope that ว่าเข้าใจว่าทุกคนได้ยินเสียงของส่งไฟล์ให้ที่นิดนึงครับเขาจะเอาเป็นบทOkay. All right. That everything is fine. ก็พิจารณาแค่นี้นะแต่เข้ามารอที่ตรงนั้นก็เยอะที่YouTube นะครับมีวิดนะครับนั่นนะครับOkay. I hope that everything is fine. Do มานะครับ Okay. All right. Here we have. Oh no. Yeah. The bigger scale for the sound นิดนึงครับ
Last Mall 99 ลดอลังปังทุกแบรนด์ลดแรงแซงทุกโปรถึง 90% และส่งฟรีทั่วไทย
All right. Hello. Yeah. Here. All right. The sound, the audio is. Oh. เข้าอีกเครื่องแต่ผมต้องปิดเสียงนี้ใช่ไหมเครื่อง
นะหวังว่าเสียงใช้ได้นะครับเสียงใช้ได้ไหมครับเสียงใช้ได้นะเช็คที่ตรงนี้นะครับ Okay. It seems that the audio is fine. Okay. YouTube เสียงใช้ได้ไหมครับ YouTube พวกสุภสินธนนัทเพชรานะครับแล้วก็กสิรินะครับเสียงที่ YouTube ออกไม่เลยที่ซูมเสียงออกไหมครับคราวที่แล้วเสียงไม่เข้านะครับก็ไม่มีใครบอกผมนะครับ I hope that everything is fine. Yeah, here. Yeah, the capital calorie is the bigger version for the same thing, which is the units. Which is the units calorie. Yeah. So we have to talk a little bit about the unit, but it's quite rare, okay, except that you pick up the problem from any book in chemistry. Yeah. The capital calorie is the 1,000 higher version of the small calorie here. Okay, it's instead of 4.186, it's equal to 4,000. Okay, 4,000 and 186. All right, and yeah, we will. It's quite rare for us in physics that we face with or we encounter this scale, the scale of the heat. Okay, all right. Yeah. Internal energy refers to the total energy of all the molecules within the object. Yeah, it's quite important for the succeeding for the next section that we will have to consider the internal energy too, right? Temperature is related. Now we arrive at the next quantity, which is temperature. All right. How could we say? Temperature is like the height, okay, of your body, and heat is like the weight of your body, and temperature is related to the kinetic energies of the molecules of the material. It is the average kinetic energy of individual molecules. Temperature is commonly associated with how hot and how cold an object feels when we touch it. And an object that feels hot usually has a higher temperature than when it feels cold. In a device of more familiar type that is used to measure the temperature is thermometer. Right? Yeah, we are going to talk about it quite often in this chapter. But nowadays there is no only thermometer. There is also other type of device, and that's if you have smartphone and if you download an application that has a functionality of scanning or telling you how hot of any object is, so that's a great thing, right? And then yeah, you can use also your smartphone nowadays to scan any object if you want to observe or you want to see any temperature, the temperature of any thing, right? Especially here in the pandemic era and pandemic situation. All right, right there. Okay, now, okay, it's not like my generation thermometer is only the single device that we could find at my era. Okay, like I was like you, 15 years old or 16 years, 18 years old. And in that era, it was only the one thing, that one device, a single device that can be used to measure the thermometer, especially when we are at the hospital. Okay, we don't use it every day. But in some other countries, for example, in the country that has a really cold weather, they usually have the thermometer at home, okay, in order to observe the weather. Okay, they would make a decision whether they will wear the jacket or not when they want to go outside out of the building or in residence. Okay, yeah, thermometer can be seen here in figure number 1. All right. Yeah, it consists of the glass, right? And we leave the mercury. Okay, usually we use the mercury, or some in some thermometers they use the the ethanol. Okay, it's a kind of alcohol. Yeah, when system becomes hotter, the liquid inside, okay, whether it's mercury or ethanol, we are gonna have the expansion of the liquid inside. Okay, so when we get hot, when we get more heat, okay, in the expansion or the rising level of that liquid is going to be high. ขออนุญาตเช็คซาวด์ตรงนี้นะครับว่าซูมเสียงไปหรือเปล่านะครับคุณอยู่กันหลายคนนะครับก็ไม่ได้แจ้งผมนะว่าซาวด์ออกหรือเปล่าเสียงเสียงออกอยู่แต่ว่าทำไมไม่รู้ว่าซูมทำไมไม่มีเสียงครับ alright ที่ซูมนะครับซูมมีเสียงนะโอเคนะครับเช็คแล้วครับ okay yeah, when the liquid expand, we will get the rising level of the mercury or ethanol, right? And the value of L increased. Okay, and we use the scale to measure the temperature of the porridge. So we have a thick area, okay, of the glass in this case, because we want the strength, okay, to hold the piece of this thermometer, and here we need to have the thin area of the glass because we want to let the heat from anything, okay, that we want to measure get into the liquids as soon as possible, okay, because if the glass is bigger, so we have to wait for a long time, okay, when we plug the thermometer into our body, so we have to wait for a long time. But if we have a thinner area for this part, we're gonna get quick results, okay, in measuring any system. Yeah, the next thing is the thermometer in the normal scale, right? You may have ever seen this in I don't know, in Mathematics 3 or something like that, you know that if you bring the ice, okay, you leave the ice into this one, you get you will get 0 degree of Celsius, right? If you leave the ice, because if there is no heat at all, and the heat outside that get into this area, you will get 0 degree, okay, out of the thermometer. All right, and yeah, that's the basic side you have met in Mathematics 3 or something like that. If we put the heat, okay, from the fire, and we boil it in until it reaches a situation when we have when there is steam or vapor here, and what we could observe from the thermometer is that the temperature here on the thermometer will be at 100 degrees of Celsius, right? Yeah, that's the freezing point, okay, and here is boiling point, okay. That's the basic scale, okay, we use to define the scale of the temperature, okay. We use water as the reference, as the freezing point and the boiling point, okay. The situation will be get vapor or steam. All right, yeah. Temperature can be measured in several ways, okay. Liquid volume of liquid, okay, that's what you get from the conventional thermometer, right? And the next thing is if you have the metal, okay, and you put the heat into this metal bar, for example, and you can observe that this metal gets more length, okay. It will provide more length to you, so it is stretched, and yeah, the length of any solid can be used as the indicator to measure the temperature. The next one is that you keep the volume of the gas to be constant, okay. You keep the gas volume constant, and then if you put the heat into that, you can get higher temperature by observing the pressure of the gas. All right, and yeah, it's not quite stable. Yeah. The next thing is we keep the pressure of the gas constant, okay, and we let it be constant, and we can observe the increasing volume of the gas, okay. Okay, only one quality you can keep it to keep it constant, and then you can observe another one, okay, pressure and volume. And in electrical system, we can also observe the heat or the increasing temperature from the electric resistance of the conductor. You let the heat pass on to any conductor, and you can observe the increasing resistance from that conductor. Okay, we also use this one in many applications. For example, you use this one in I don't know what is that. It's in the radiator in the car. Okay, you know the radiator. ภาษาไทยเรียกว่าหม้อน้ำใช่ไหม in the radiator in the of the car, okay, we have a sensor, okay, that touch the water, that flow around the engine, right? And that sensor use this technique, okay? When the water from around, when the water flown from the engine around the engine gets more temperature, gets higher temperature, the resistance of that sensor is going to be increased, and yeah, we could let the current flow and we can observe the temperature from that property. Another way is that you look at the fire directly by eyes, you can classify the temperature by observing the color of that fire, okay, or any object. Okay, temperature is the measure of hotness or coldness of on some scale, but what scale we are going to use, okay? Of course, you may have ever seen the temperature unit in degree of Celsius, okay? That's the most familiar with, that's the most familiar unit that we have seen when we are in Thailand. But if you have ever been in the United States or even in the British, in Great Britain, they also use a different temperature unit. Okay, the most familiar one is centigrade. Okay, centigrade seems to be an ancient word. All right, it's not the modern word, and yeah, we use it for long time, even while I was a child, okay, in my secondary school, okay, and, I was a person who is chosen by the school to get into the competition in science and so on, science. So yeah, I still was taught to memorize the unit of the temperature by using the words centigrade, okay? And nowadays the people use doesn't often hear these words, the centigrade one, okay? We rather use the surname of this person, okay? His name is Anders Celsius, okay? Or simply speaking, Celsius, okay? Yeah, the Celsius scale is derived from the water property, right? At the freezing point of 0 degree and at the boiling point of 100 degree of Celsius. Okay, yeah. C can stand for centigrade. Okay, why I was shy, and Celsius is also the C version of the unit, right? But it's but it comes from the surname of this person, Anders Celsius. Okay, and the temperature for a substance colder than freezing water is a negative number in degree of Celsius. Right? Yeah. If you have anything like dry ice and so on, okay, it's on the order of minus blah blah blah. It's a degree of Celsius because it's really very cold, right? And yeah, if you have ever been in any area in Russia, okay, in their winter they would have something really less than 0 degree. Okay, sometimes in Siberia they have minus 50 degree of Celsius, right? And if you want to keep the meat, okay, you just leave it outside the home, okay, and the quality of the meat is going to be kept well. Okay, you don't need to buy refrigerator at all. And like I was in Germany, okay, I have done the doctoral degree, the PhD on, it's not PhD, okay, it's known in doctoral degree in Germany. While we were in winter, the temperature is less than 0 degree. There was snow, and we just left the bottles of beers outside the water at the windows, okay, and that's what really happens when you live in a country that is really cold. Okay, yeah, the negative value of on the Celsius degree means something frozen. Okay, Celsius scale is used both in everyday life and in science. Okay, if you do the laboratory, most of the measurement rely on the Celsius scale. And if you work in a company, in a factory, most of the things will be measured in Celsius scale. Okay, but there is an exceptional case, for example, in the United States, okay, the USA, and a few other English-speaking countries, like New Zealand or in Australia. I have never been there. Okay, and people often use also the people often do not use the Celsius scale, but rather they use this scale. Okay, this person, Daniel Fahrenheit. Okay, Daniel Fahrenheit is a person who observed something about heat, yeah, and temperature, and he built up his own scale, right? And yeah, it's called it's known according to his surname. Fahrenheit scale is still the most frequently used temperature unit in the United States. Okay, if you have a plan to study in the United States, the people use different units. Okay, they use new way to say about the weight, right? In pound, they measure the height of their bodies in feet, right? In foot, in feet, something like that. And also one of the things, the temperature is going to be measured and not in degree of Celsius, not so often, but they would use Fahrenheit scale. All right. Okay. Yeah. The next thing is we see the comparison between the Celsius scale. Okay. If in modern, if you are the owner of the company that produce the thermometer, okay, you should offer two scale, okay, so that you will have more chance to sell the product in different area around the world. Okay, that is your opportunity, okay, your benefit, your chance in the market share. Yeah, in some thermometer they provide two scale simultaneously. The left one is on the Celsius scale. The right one is shown in Fahrenheit scale. Okay, so let's see the basic property of substance. Okay, we consider the boiling point and the freezing point of the water, right? The freezing point of the water is, as you know, at 0 degree of Celsius, and it's equivalent to it's equivalent to what is that? It's equal to 32 degree of Fahrenheit. Okay, exactly the same. And the boiling point of the water is steam. When we get steam of the vapor of water, right? At 100 degree of Celsius, and you get 212 Fahrenheit degree of Fahrenheit. And yeah, the room temperature most scientists refer to is at 20 degree of Celsius, right? And yeah, 20 degree of Celsius is not the room temperature in Thailand, because we rarely have the temperature at 20 degrees of Celsius, except that you stay inside the building and you turn on your air conditioner. Okay, but if you get out of the building, it's quite rare, except that we are in winter. Okay, this is, I would say, the room temperature for the North America people or for the European people. Okay, the body temperature is quite standard in every country. So we often use this value in order to classify which person get trouble with pandemic or COVID-19 or not, right? Yeah, as the situation goes on, you can see the temperature everywhere. You go to the shop, to any store, right? At the entrance, they often provide a thermometer to measure, right? And 37 is the value for the normal or typical, I would say, typical body temperature, right? Okay. But it's not the case. Okay, under Celsius and under Fahrenheit, they provide temperature scales for different areas around the world. Okay, but mostly they are related to the water, right? And several applications outside. But when the science has developed quite a lot, and scientists has found that the degree of Celsius, the Celsius scale of Fahrenheit might not be so convenient in order to analyze some properties of the substance on Earth or even in the space, right? Because they have measured some properties of gas and so on, and they find that another scale would be more appropriate when we when we do the experiment in science, or when we make the measurement of any object temperature in science. So the people has observed, the scientists have observed the gas and okay, the expansion of the gas and the volume of the gas together with the liquid. This liquid is mercury reservoir. Okay, and they measure the temperature and the pressure together, right, along the x-axis, and they found that when we increase the temperature, we get higher pressure. And yeah, they make several experiments. Okay, they make several trials, and they found that if they plot the result on the typical graph scale, this line is gonna bring you to the same point. Okay, these three trials, these three experiments will bring you to the same point, and this point is equal to minus 273.15. Okay, but for you at the high school level and maximum 6, it would be sufficient to use only value minus 273. All right, yeah, and that would be sufficient. Okay, you don't have to be so precise like me, but in many cases I often use 273.15. Okay, because I want to be precise. Okay, yeah, they have got several experiments, and all experiments bring us to this point. Okay, minus 273.15, and this will be the lowest temperature of any substance that the scientists has observed. Okay, yeah. So how often could we deal with the Kelvin scale? This scale is called Kelvin. Okay, I we would say at this value, we would say it's the absolute temperature value. It's 0 Kelvin. Okay, that's the lowest temperature any substance, any object could have. Okay, the scientists believe that. Okay, in the space. Okay, there should not be no lower temperature than this. Okay, and the person who observed first is this person. Okay, in 1948, or sorry, in 1848, he know that the molecule stopped moving at absolute 0. Okay, it's called absolute 0 temperature, and he proposed an absolute temperature scale, okay, which is now called Kelvin scale. But his name, why he was born, is not Kelvin. Okay, Kelvin is the length. That is what you may get if you live in England, in Great Britain, in United Kingdom, and you have done a lot of good things. It's like you are the trainer of a soccer team like Manchester United, but I'm not a fan of Manchester United. Okay, and the famous trainer of Manchester United is Alex Ferguson, right? Yeah, if you done something that has big impact to society, you may get the rank, okay, from the royal family in Great Britain. For example, Alex Ferguson get the Sir title, right? And yeah, William Thomson is the name that since he was born, and he made something good to the society in England and got the rank which is known Baron Kelvin. He was the first person who got this rank, and yeah, the people just used the surname of this position. It's called Kelvin scale. Okay, but his exact name, since he was born, is William Thomson. Okay, yeah, Kelvin scale is the temperature scale that is used commonly in science. Okay, it's not the normal temperature when you touch on. When you get into the supermarket or department store, okay, and you want to measure your body in Kelvin scale, okay, no one is gonna realize or understand that, okay, because it's not commonly used in daily life. Okay, but if you work in science, if you are physicist, if you are chemist, okay, and you experiment in laboratory, of course, the appropriate temperature scale is Kelvin. Okay, but it's not the daily life scale. Kelvin scale is the absolute temperature scale defined to have 0 Kelvin at the lowest possible temperatures. So that's why they call absolute 0. Okay, they believe that, I'm not scientist. Okay, I don't have deep knowledge inside. They believe that any matter in the space should not have the temperature less than this. Okay, and absolute 0 is the temperature at which everything, including air, freezes solid. All right, but I'm not sure. Have you ever seen the air get solid at -273? Because it's quite hard to have that environment. Okay, the environment with -273 degrees Celsius. Okay, even -70 to keep the Pfizer vaccine. It is also difficult for us in Thailand to have that moment. Okay, unlike other temperature scales, Kelvin scale is an absolute scale. Okay, you cannot have any other scale that can capture all the details of the matter anymore. Okay, better than this. I'm not sure. Okay, because when the time goes by, someone may propose a new thing. If you fall in love with physics or in science, you may work in university or in any research center, and you may develop your own temperature scale that is more appropriate to what you discover in the laboratory. Okay, and when you pass it away, the people are gonna use your surname as the temperature unit. All right, yeah. What else? I think there is also another unit scale, right? The temperature unit, which is called Romer, right? But we would not talk about Romer scale. Have you ever heard the word Romer, right? Romer is the Daniel. It's the Danish name, right? Yeah, it's a kind of temperature scale. Okay, and there is a formula between Romer and Kelvin and Celsius too, right? Yeah, but if you are interested, and you can browse the information by yourself. Okay, the name is taken from the Danish people. Okay, yeah, this is the experiment. Okay, in order to find to discover how the Kelvin scale emerges. The constant volume of gas thermometer measure the pressure of the gas contained in the flask immersed in the bath. Okay, yeah, you can see the volume of the gas in the flask is kept constant. Yeah, and by raising up or lowering reservoir B. All right, yeah, to keep the mercury level in the column A constant. Right, yeah, there is also another thermometer which is uses that idea. Okay, it's called constant volume gas thermometer. Like this. Okay, you can even measure the ice. Okay, anything that has really extreme temperature. Okay, yeah, this one we have already considered. Yeah, this one is also the same thing. Okay, but it's taken from another book. This one is taken from the book number 4. This is from book number 1. Plot of pressure with respect to time. Okay, and yeah, this one is more detailed. You know that the water get frozen at 0 degrees Celsius, and you can get higher temperature for the water, and the water cannot be less than this. Okay, minus 273. At this point, okay, everything is gonna be in solid state. Okay, everything will be solid, and that slide show the plots extrapolates to 0 pressure. Yeah, because of the development inside, we need to have this scale. Okay, it's another kind of temperature, but it's measured in Kelvin. We say this one is 0. Okay, 0 Kelvin. Pressure versus temperature at constant volume of 3 gases. Okay, they use different gases to get these plots. And let's talk about the thing that happened in space in nature. All right. So let's start from the lowest temperature. Okay, the lowest temperature is around 10 Let's to the negative 10. Okay, it's almost zero, right? Almost zero. And yeah, at 1 Kelvin, okay, around something of 1 Kelvin, 2 Kelvin, and so on. The helium gets liquid state. The helium gas, okay, gets the liquid state. And if you are at something 11 Kelvin, your hydrogen, okay, hydrogen is a gas, right? But it's gone down to liquid. It's gone down to be liquid around 11 Kelvin. And if we are at 60 or 70 Kelvin, the nitrogen got the liquid state, and the water freezes at what is that? It's 0 degree of Celsius, right? And it's around 273.15, right? Yeah, the water gets frozen, and at the 1000 Kelvin, 1000 is really high, right? It's around 800 or 700 degree of Celsius, something like that, or 700 degree of Celsius. The copper is gonna change their phase from solid to be liquid. It's get melt, it's get molten, and oh my God, it's around 5,000 Kelvin, which is around 5,000 degree of Celsius too. You can reach the skin, the surface of the sun. Okay, but we would not have any aircraft to get there. Okay, because it will be completely destroyed. Okay, let's go somewhere which is quite far from our Earth. Solar corona has a temperature of 1 million Kelvin. Okay, this is what the scientists expect. They could expect from the color of the lights. Okay, they could not have any chance to get there. Okay, I don't know, maybe in the next million years the human can develop any spacecraft and so on to get there and to measure the temperature. Okay, they measured by using the spectrum of the lights. Okay, when they observe from the deep space and inside the sun. Okay, the scientists believe that the temperature is around 10 million degree of Kelvin, and hydrogen bomb, okay, which is a kind of nuclear fusion process or something like that, gets 100 million degree of Kelvin. Okay, that's those million and trillion, billion, and so on are quite far from us on Earth, right? But that's what the scientists or physicists expect in the deep space. Okay, and that's why the Kelvin scale is more universal. Okay, it can capture the tiniest particle until the biggest particle in space, right? Okay, let's compare all these three temperature scale. Okay, we don't talk about the Romer scale, but if you want to get some idea, yeah, go to a website, okay, to see the idea of Romer scale. D by 5, R by 4, right? That's the equation. Okay, the steaming point of the water standard one is at 100 degrees of Celsius, and the frozen point for the water is 0 degrees, equivalent to 32 degrees of Fahrenheit, 212 degrees of Fahrenheit. And on the scale, Kelvin scale, we get 373.15. Okay, it's only 100 more than the freezing point, which is 273.15 Kelvin. Okay, and you can see the pitch here between two bars on the Celsius and the Kelvin thermometer would be on the same length. Okay, but the one by Fahrenheit will have tinier, smaller pitch of 2 bars. And what else? Yeah, the absolute zero, which is 0 Kelvin, is minus 273.15, and on the Fahrenheit scale, you can get negative 459.67, and here is the abbreviation. Freezing point of water 32 right 0 degrees Celsius, 273.15 of Kelvin. Normal body temperature now 37 right on the Kelvin scale is 310.15, but you cannot say this number to the department store. Okay, your body is perfect, it's normal, you have 310.15 degrees, but degrees of Kelvin. Okay, the people cannot realize that. Okay, we use the normal 37 degrees of Celsius. We talk to each other, and on the Fahrenheit, for example, if you live in the United States, they would use this number 98.6 degrees of Fahrenheit. And the boiling point, okay, if you do the laboratory in the United States, they would say 212, but for almost everywhere in the world, we would say 100 degrees of Celsius. And in the strict laboratory, they would say 373.15 degrees of Kelvin. Of course, let's consider other stuff. For example, oxygen try to be in liquid phase at negative 183, but it's really hard to get this situation. And negative 78, okay, that's quite in the same level as the keeping temperature for the Pfizer vaccine, okay, negative 70 degrees. So at this level, negative 78 degrees of Celsius, or 195 or negative 109 in Fahrenheit, the carbon dioxide start to be solid. Okay, and yeah, the water. Okay, this is what we have already considered. There is difference in 100 Kelvin. Okay, in between the freezing point and boiling point of water, and also 100 degrees in Celsius scale for the freezing point and boiling point of water. But there are 180 degrees between the freezing point and the boiling point on the Fahrenheit scale. Okay, they have more pictures. Okay, they have more details here. Yeah, if you want to convert the temperature scale from one to another one, you may have to consider this table. If, for example, if you want to convert the temperature from Celsius to Fahrenheit, okay, the output is on the left-hand side, the input is on the right-hand side. You get 9/5 of temperature in Celsius plus 32, and they can also say something like this. Okay, without parentheses. From Fahrenheit to Celsius, you have to use the opposite ratio. Okay, the inverse ratio 5/9. Temperature in Fahrenheit minus 32 degrees. Okay, and if you want to convert Celsius to Kelvin, it's quite simple. You just add 273.15 to the temperature in Celsius. If you want to convert it Kelvin to Celsius, you just deduce the temperature in Kelvin by 273.15, and you get the temperature in Celsius. If you want to convert the Fahrenheit to Kelvin, it's like you do the change between Celsius to Fahrenheit. the next thing is that you have to add to 73.15 to the result, okay, to get the value for the Kelvin. And if you want to get Kelvin from Fahrenheit, you just use this expression. I don't know, you have to reduce it first by 273.15, and then you convert it by using exactly the same expression here, okay? 9/5 and plus 32. Okay, that's the whole thing. Yeah, the formula for the conversion between Fahrenheit and Celsius is 9/5. And what else? There is an example in temperature scale conversion. เราต้องจบที่ไหนใช่ไหมผมต้องปล่อย9 Room temperature is known as 25. Okay, some areas say 20, some areas say 25. Doesn't matter. And what is the room temperature in Fahrenheit, and what is the temperature in Kelvin? Okay, the room temperature in Kelvin. Yeah. Now, กันดาพลเน็ตล่มหัวข้อตามสบายครับสุรปวีขอโทษครับแบตหมดไปสบายตามสบายครับคุณอยู่ที่ YouTube ก็อยู่กันไปตามสบายนะครับถ้าเสียงติดขัดยังไงแล้วแจ้งผมทันทีนะครับมีคนไหนปกติถ้ามาถึงตรงนี้นะครับเพราะผมไม่ได้ทำโซลูชันผมจะให้คุณทำนะจะให้คุณแก้ก็มีคนไหนสนใจว่าจะทำโจทย์นี้ใช่ไหมไม่ใช่แบบมันไม่มีวิธีทำด้วยนะใช่ไหมมีคนไหนสนใจทำไหมครับมีคนไหนสนใจทำไหมช่วยทำให้ดูหน่อยว่ามันตอบเท่าไหร่ alright มีใครทำได้ไหมครับเปิดไมค์ช่วยด้วยครับบางคนอาจจะไปแบบว่าเรียนพิเศษข้างนอกมาแล้วอะไรเงี้ยก็บอกได้นะครับใช่ไหมทำยังไงhow to resolve this นี่นะครับพอเป็นออนไลน์ปุ๊บแอคชั่นเราจะไม่ค่อยได้นะใช่ไหมครับก็ถามตอบกันก็จะลำบากไม่เหมือนห้องจริงนี่ผมแรนดอมชื่อนะครับซึ่งมันก็เมื่อนานมาแล้วนะครับที่ได้สอนห้องจริงครับถ้าเป็นห้องจริงเราก็จะแรนดอมชื่อแล้วก็ให้คุณออกประทำหน้ากระดานนะครับแต่ว่าบรรยากาศนี้มันไม่มีอีกแล้วไม่ใช่ไม่มีอีกแล้วมันคงนานis there anyone who is interested solving this problem? Anyone interested in this? Yeah, the room temperature 25, right? And we want to convert it to the Fahrenheit and to the Kelvin, right? Fahrenheit, Kelvin. So we have to see Celsius to Kelvin, and we have to consider Celsius to Kelvin and Celsius to Fahrenheit, right? So this one, right? It's what is that? T in F, right? T in F is equal to this expression 9/5 plus 32, right? 9/5 of T in Celsius plus 32, right? And you just leave it. It's 9/5 times 25, right? In plus 32, you will find that it's 45, right? 45 and 77, right? 77, 5. Okay, and that's it. Okay, one thing that I have to mention, there's no battery at all. Yeah, what I forget to mention is the following. You need to know that both Fahrenheit and Celsius scale, both Fahrenheit and Celsius scale here, okay, would have the small circle in front of that. All right, yeah. There will be small circle in front of F and in front of C, but for K, which is the absolute temperature scale, there will be no zero at all. Okay, all right. That's the one thing you should realize. Okay, don't be trained to write down the small circle in front of K for the units of the temperature. For the temperature by Kelvin, okay, there will be no circle at all. All right, yeah, it's the next thing. Now we arrive at the problem of Kelvin, right? K is 273.15 plus TC, right? And it's 273.15 plus 5. It's gonna be 298.15 Kelvin. Okay, without the small circle at all. All right. Let me change the note. Yes. All right, on 8. Okay. Yeah, here. Next thing. We arrive at the next example, which is the temperature unit conversion problem. Yeah, we arrive at the next example, and here is the temperature gradient between the skin and the air is regulated by Coolness. Who know this word? มีใครทราบคำนี้ไหมเป็นศัพท์แพทย์นะผมเรียนวิศวะนะไม่ได้ยุ่งกับศัพท์พวกชีวะมานานโขครับไม่คุ้นเคยนะครับ Is there any idea about it? Cutaneous skin blood flow, right? And if the cutaneous blood vessel ภาษาไทยเรียกว่าอะไรเส้นเลือดฝอยหรือเปล่าใช่ไหมเส้นเลือดฝอยนะครับ Alright, is that correct? ใช่ไหมเอ่ยคนไหนเก่งชี้ว่าครับคำนี้แปลว่าเส้นเลือดฝอยใช่ไหมครับyeah if the cutaneous blood vessels are constricted the skin temperature and temperature of the will be about the same. All right, in when the vessels are dilated, more blood is brought to the surface. Okay, when the vessel is is expanded. Okay, and the body use this system to control the temperature inside our body. And suppose during dilation the skin warms from 32 degrees of Celsius to 82 in 82 Celsius or Fahrenheit, sorry, and convert this temperature change the temperature change from Fahrenheit to Celsius and from Fahrenheit to Kelvin. Okay, and again find the difference. Okay. Yeah. Is there anybody who is interested in solving this problem? มีใครสนใจไหมครับทำออนไลน์แล้วเปิดกล้องให้เพื่อนดูหน่อยก็ได้ Anyone who is interested มีใครสนใจไหมครับ Anyone who could solve this แจ้งที่ช่องหนึ่งไม่มีใครก็ฝากไว้นะครับ Okay, all right, here. Okay, yeah. We have to convert first the 72 to 84, right? In F2C, right? F2C. So let's take a look at the table. I also cannot remember. Okay, F2C is going to be this one. Okay, Fahrenheit to C, 5/9. Okay, T 72F, right? It is going to be converted to T in degree of Celsius, right? So we would formulate this one by using this expression TF, right? In oh no 9/5, 5/9. Uh, 32, right? And then 5/9, okay? And we leave the temperature of F into this expression. All right. 5/9 divided by 72 minus 32, and it's going to be 5/9 times 40, right? And yeah, we leave it in the calculator, right? 200/9. Okay, let's say it's 200/9. It should be something around 10, right? 200/9.
Loading in progress.
200/9. It's going to be 22.20. Okay. It's approximately 22.22. in the unit for the degree Celsius. Right? Yeah. And let's continue our story in next thing is 84, right? So TC, right, 5 by 9 of 84 minus 32, right? It's gonna be 5 by 9 and 5 2, right? 5 and 2, and it's 260 by 9. All right. Let's use these one. 260 by 9. 28.88. 28.89 approximately, and that's the unit in degree of Celsius. And what else? The difference, right? Difference. So it's gonna be delta T in degree of Celsius is gonna be 28.89 minus 22.22. It's approximately, I would say, and 6.67. Another way is that you can change the difference here. We can see the difference, which is 12, right? 84 minus 72, right? It's 12, and just use the 12 times 12 times 5 by 9. Oh, it's gonna be 76. Yeah, right. 6.67, 6.6666. All right, yeah, you can use the difference and times the scaling factor 5 by 9. All right, in order to find the difference. Okay, or you can find the difference directly from both values. So let's consider the temperature in Kelvin. Right? Kelvin. Kelvin is quite simple. You just 273.15 plus temperature in degree of Celsius. At the first state, T1 is this one, right? 22.22, right? So it's 273.15 plus 22.22. You would get approximately 295.37. This is in Kelvin. For the second temperature, you get 273.15 and plus 28.89, right? And you get yeah, here 4 approximation. เป็นผลต้องปล่อยคุณแล้วสิหมายก่อนจบนี้กันแล้วกันนะครับเลยนิดนึงนะผมเซตเครื่องเสียเวลานะครับขอสักจนถึง10 องแล้วกันนะ 5 and 9 is going to be 4, right? And this is 0 and 1, right? This is 12 and 1 again. 3 and the 2, right? Let me check it. เพื่อความชัวร์นะมันสอนคุณอัดผมไม่ผิดครับ 273.15 plus 273.15. Yes, it's correct here. Okay, it's the second temperature, and you get the difference, right? You want to find difference, so delta T is equal to T2 minus T1, right? And it's equal to R7 and 9.6 9 All right. Yeah. Okay. Yeah. You just use 9/5 factor and leave it to the factor TC. Okay. And it's going to be 9/5 and number 2, right? So it's 18/5, right? So it's equal to 3.6 degree of Fahrenheit, right? But regarding the temperature difference in Kelvin, okay, because of this expression, T Kelvin is 273.15 plus T in degree of Celsius, delta TK is going to be directly the same as delta TC. All right, so it's, as you know, this one is the 2 degrees different, right? 2 degree difference, so it's going to be 2, right? Kelvin. Okay, and that's it for this exam. All right, หมดเวลาพอดีนะครับก็ 10 โมงครับก็แจ้งคุณนะครับการบ้านนะครับได้เป็นคะแนนเก็บครั้งท้ายๆนะครับอย่าพลาดนะครับการบ้านให้เลือกเอานะครับก็คือเรื่องคราวที่แล้วนะคือเรื่องเขาเรียกว่าเอปซิลอนทีเท่ากับบานโอเมก้าไซน์โอเมก้าทีครับแล้วก็ครั้งนี้นะครับเรื่อง temperature change นะครับการ convert อุณหภูมินะครับการ convert อุณหภูมิก็หลักๆก็ใช้ตารางตรงนี้นะเดี๋ยวผมเขียนใน Google Classroom ให้อีกรอบหนึ่งเรื่องการบ้านนะครับย้ำนะครับการบ้านนะครับเลือกได้นะครับ2 เรื่องนะครับก็คือเรื่องtemperature change นะครับตรงนี้นะครับก็คือการเปลี่ยนยูนิตของอุณหภูมินะครับจากตารางนี้แล้วก็อีกเรื่องหนึ่งก็คือเรื่อง generator นะครับก็คือ epsilon t equal bar omega sin omega t. All right. Is there any question regarding the lecture of today? มีคำถามไหมครับ You have any question? If not, we're gonna leave our lecture right now, okay, and see you on next Thursday. Okay, next Thursday. สวัสดีครับบ๊ายบายครับ Next Thursday. No one Alright โอเคครับSCI 33205 welcome you to SCI 33205 this is the section for M605 right and I have two things to inform you right let's check the sound. All right. Yeah. Two things that I have to inform you is the following. The first one is something about the midterm, the final exam, right? Yeah, as same as in midterm exam. Okay, we are gonna have 2 times for the exam, okay, so that you can get less stress and you can have more time. And of course, we have the content in the second chapter, right? In you can have 1 week to remind yourself about the second chapter, and we would have the final exam on the 10 คนมาที่หลังครับวิชอะไรจะรู้เรื่องไหมครับโอเคสำหรับอธิษฐานครับสำหรับคนที่มาทีหลังครับก็จะพูด2 เรื่องครับวันนี้นะครับนอกเหนือจากเนื้อหาที่จะเรียนกันครับจะแจ้งคน2 อย่างก็คือเรื่องแรกนะครับก็คือ the first thing is the midterm exam the final exam alright and because we have 2 chapters, right? The second chapter and the 4th chapter that we are dealing with right now. And for the second chapter, we will have the exam on 10th of September. Is that all right to you? No, 10 is not possible. It would be yeah, it would be possible 10. Okay, I hope that because I have also the class for teaching on the 10. I hope that on 10, which is on the next week, right?
ครับวันที่10จริงๆผมติดนะแต่ว่าสอบคุณมันไม่ต้องออกเสียงอะไรครับก็สามารถสอบคุณได้อยู่ครับalright on 10 which is yeah it's Friday it's no problem there is no conflict at all on 10 we would have the final exam. I'm not sure whether you could see. Okay, on 10th of September, we would have the final exam for the second chapter, which is something about magnetism and electricity. All right, พิรทัศน์เพิ่งมาจะทราบนี่เพื่อนบอกด้วยแล้วกันนะ And I will tell you later about the number of problems, but it's in the same style as the midterm exam. Okay, you have to choose the number, and the problem is exactly the same as in the lecture notes. And yeah, because I need to have more time, okay, to avoid the error in checking your problem in the exam, okay, to avoid the errors. So I need to have more time. Otherwise, if you let me do it for only few days, 1 or 2 days, it's very stressful. It's prone to error. It's quite sensitive to the error. So after 10, we would have the exam again. We would have the exam again on. We would have the exam again on 17. Okay, that's the last day we could do the final exam, and we have almost 1 week. All right, and yeah, and the final score should be delivered to the school on 19, and the grade submission will be done by your co-teacher at the SK school on 21st. All right, so it's the grade will be filled into the system by your co-teacher, and yeah, that's what we could do. I hope that everyone in M605 has submitted his own homework completely perfectly already, right? And I don't know what's going on with Tilut. Maybe we would leave him, I think, but some of you say that he has left the school because he has got the rights to the military school in, but your co-teacher, the teacher คุณครูเลยนะคุณครูผมลืมชื่อแล้วนะครับผมรู้แต่ชื่อเล่นครับโอเคไหมyour co-teacher said to me that I have still keep the record for T-root, so that's why I didn't remove him from any file at all, right? And that's the first thing. Okay, all right, about the final exam. 10 next week, right? Next Friday for the second chapter about magnetism and electricity. Anything that is succeeded from the content in the midterm exam. Okay, we will have it as the final exam contents until the end of the second chapter, and we would have few problems for the fourth chapter, which is this chapter, the heat and gas. Okay, all right, that's the first topic we were discussing, and the second topic is that the second story is that I have to inform you that we would have homework. Okay, I don't know, this might be the night homework, I don't know. Yeah, okay, the night homework will be the problem about generator, which is epsilon equal ban omega sine omega t. Okay, that's the first choice for you. For the second choice, I'm not sure. For the second choice, I'm not sure I have share the screen, not yet, right? Okay, for the second choice, the second choice is that you can do also the homework regarding the temperature conversion, which is going to be shown here today. This for today lecture, this one. Okay, the problem about the conversion of the temperature units. Okay, Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Celsius, Fahrenheit, Kelvin, Kelvin to Fahrenheit. Okay, we will have 3 examples for the conversion of temperature, different temperature units like this. Okay, and you can also choose this one as a choice. Okay, in summary, the first choice for you to do the homework is the generator, okay, which has the formulas epsilon t equal ban omega sine omega t. Ban mean BAN, okay, B magnetic field, A is the cross-sectional area, N is the number of turns of the coil, and omega is the angular speed of the rotation axis or the rotor, and sine omega t, right? And that's the first choice. The second choice is the temperature conversion, which is what you are going to see here in today's lecture. All right, everything is fine, right? I hope that nobody is going to have any trouble with the final exam. The exam style would be the same. Okay. Yeah, we have stated already the something about the temperature, right? We have talked about this one, temperature. Okay, as we know from yesterday, temperature is like the height, okay, and the height of your body, and heat is like the mass, okay, mass of your body, and yeah, we have discussed this yesterday. The temperature, the thermometer, that is the tool to measure the temperature, right? And the liquid inside can be either mercury or ethanol, okay, which is a kind of alcohol. And yeah, the freezing point for the water is at 0 degrees of Celsius, and the boiling point of the water is all right, everything is fine. The boiling point of the water is 100 degrees of Celsius. And is there anything else? Yeah, the way we could measure the temperature could be in many aspects, could be done in many ways. The first way is that you can observe the volume of the liquid, okay, which is a kind of what you can see here inside the thermometer. All right. The next thing is that if you have a piece of metal bar and you inject the heat, okay, you put the heat to it, and the bar is going to be hot, and it can increase its length, okay, and yeah, that's one way. In have you ever seen the railway for the train? ใครเคยเห็นรางรถไฟไหมครับเคยเห็นไหมเคยเห็นรางรถไฟไหมครับถ้าคุณเคยไปสถานีรถไฟคุณจะเห็นรางรถไฟคุณจะเห็นว่ารางรถไฟเหล็กรางรถไฟนะครับมันไม่ได้เป็นเหล็กเส้นเดียวกันแล้วต่อเลยนะไม่ใช่แบบเหล็กยาวเส้นเดียวกัน คู่ขนานกันไปตลอดไม่ใช่อย่างนั้นนะมันเป็นเหล็กทีละชิ้นทีละชิ้นแล้วมาวางเรียงกันเห็นไหมครับเห็นไหมเอ่ยนั่นแหละนะครับเดี๋ยวพาไปดูเหล็กรางรถไฟก่อน Let's consider this. I'm not sure whether you could see it or not. All right. Is there any example to that? Oh no. Here I hope that there would be some image. No. Let's consider the image. Where? Here. Okay, here. You can see, right? You can see here, right? There is there is a space here. Okay, you can see that the piece of metal is not a single one. Okay, it's made of two pieces of metal. What is the reason behind it? คุณทราบไหมครับว่าทำไมเขาเป็นแบบนี้ทำไมเนื้อเหล็กต้องเป็นเหล็ก2ชิ้นแบบนี้มีตัวอย่างอื่นอีกไหมThese one. Oh no. Here. All right. Yeah. มีใครตอบได้ไหมครับเปิดไมค์ตอบหน่อยว่าบริษัทเสียเวลาหาทำไมเป็น2ชิ้นแบบนี้ทำไมเขาไม่เอาเป็นเหล็กเป็นอันเดียวกันไปเลยทำไมไม่เชื่อมออกติดไปเลยเป็นแบบติดกันแบบกาวตาช้างเป็นแน่นเป็นชิ้นเดียวกันทำไมวางเชิญครับเชิญ
ขยายอะไรนะครับของราง
มีคนตอบแล้วเนี่ยใจคุณจะเห็นรอยต่อเห็นไหมครับมีตลอดมันจะยาวสัก100 เมตรหรือว่า70 เมตรอะไรเงี้ยมีคนตอบไปแล้วนนทกรบอกว่าป้องกันการขยายตัวคุณเห็นไหมเหมือนกันนั่นแหละครับเรากำลังเรียนเรื่อง temperature ใช่ไหมการวัดอุณหภูมิของสิ่งของเห็นไหมเนี่ยคุณเห็นไหมครับเนี่ยร่องสีเหลืองเนี่ยเห็นไหมนั่นแหละคุณเห็นว่าเขาเหลือไว้เห็นไหมอย่างที่นนทกรบอกนะครับก็คือว่าเหล็กมันอยู่ข้างนอกมันไม่ได้อยู่ในอาคารในร่มนะครับมันโดนแดดใช่ไหมครับ พอโดนแดดมันทำเป็นไงมัน get heat อ่ะมันได้รับความร้อนนะครับมันก็เรื่องนี้เลยนะครับ length of a solid alright นะครับไอตัวเหล็กรางรถไฟอ่ะก็เป็น solid เป็นของแข็งชนิดหนึ่งพอมันโดนความร้อนมันจะขยายตัวนะครับขยายตัวออกข้างด้วยด้านยาวด้วยโอเคไหมพอมันด้านยาวเขาก็ต้องเหลือที่ไว้นะครับไม่ใช่แบบว่าจับชนกันเป๊ะๆนะครับโอเคไหมถ้าเป็นคนซื่อตรงเขาก็คงเคยลองสร้างมาแล้วแหละแล้วปรากฏว่ามันผิดพลาดนะพอมันดันกันนะครับถ้ามันชนกันเลยนะจับวางทีแรกไม่โดนแดดเนี่ยจับชนกันปุ๊บพอโดนความร้อนปุ๊บมันจะดันกันนะครับพอมันต่างฝ่ายต่างขยายตัวนะครับอันนี้ก็ยาวขึ้นอันนี้ก็ยาวขึ้นมันก็ชนกันโอเคไหมอันนี้เขาเหลือไว้เพื่อว่าเหล็กพอมันโดนความร้อนแล้วนะครับโอเคไหมมันก็จะขยายตัวนะครับso we use this principle too alright in order to observe the temperature increases of any stuff okay another one is the pressure of the gas held in a constant value if you have a constant value glass you get more pressure from gas okay when you put the heat into it in if you keep the pressure constant and if that subject can be expanded for example the balloon okay balloon is an example this one okay yeah this one if you lay down the balloon outside มีคนเลข20หมายเลข20นี่คือใครไม่เขียนชื่อมาผม all right if you have the balloon like this and if you leave it outside for example with the sunlight okay it gets heat okay from the sunlight and you can see that if the pressure inside the balloon stay constant ขออภัยนะครับเน็ตผมหลุดนะครับไม่ก็เน็ตผมหลุดนะครับขออภัยด้วยครับอยู่ดีก็หลุดนะครับ alright this one okay in Thailand maybe we would not have that situation Siberia Siberia in Russia yeah Siberia with S okay Siberia in Russia is written here oh no yeah Siberia okay this is a part of Russia and you can see their location in winter yeah you can see the weather there in winter they can have like in January for example they can have like -20 okay and the highest amount is -12 okay and in the worst situation they can have even during the night time okay -50 degrees of Celsius okay it's very hard to live there and the people would not go out to work at all okay because it's very hard to get out of the home and yeah there will be always the snow you can imagine this right yeah okay it's very cold there and yeah we get the temperature which is really less than freezing point of the water and we would say it's a negative number in degrees of Celsius okay and the Celsius scale is used both in everyday life and in science and industry okay if you plan to work as scientist on the laboratory มีคนถามผมว่าผมหลุดแน่นอนเลยมีคนถามเสียงหายครับ10:50 oh I'm sorry for that เสียงหายครับ
ที่YouTube มันจะมี2ช่องนะคุณลองดูก็ได้นั้นจะใช้
ไมโครโฟนอีกอันหนึ่งนะครับไม่รู้ผมส่งลิงก์ให้คุณแล้วหรือยังที่เดี๋ยวหาลิงก์ให้ได้อันนั้นจะเห็นตัวผมด้วยนะอันนี้เห็นแค่หน้าจอเดี๋ยวส่งลิงก์ให้แล้วกันลิงก์ที่ YouTube ตอนนี้ก็มีคนดูประมาณ2 คนแต่ลิงก์อันนี้มันแต่ YouTube ที่คุณดูนี่มันเป็นมาจากซูมถ้าซูมเสียงหาย YouTube ก็จะเสียงหายด้วยครับแต่ว่ามันจะมี YouTube อีกอันหนึ่งที่แบบพิเศษเลยWhat's going on we have live เสียงมาแล้วหรือยังครับเสียงครับI'm not sure about it this one let's see yeah this one the link hereเดี๋ยวส่งให้นะครับอันนี้นะลองกด ลิงก์นี้คือนะครับต้อง copy ไม่รู้คุณเข้าได้หรือเปล่าวันนี้นะแล้วพี่พลครับคือผมไม่เข้าใจว่าทำไมอาจารย์หนึ่งไม่ขึ้นไลฟ์กันKU ใน SCI นี่จริงกำลังไลฟ์ทำไมมีอันเดียวไม่เข้าใจครับจริงมันมี2 อันนะลิงก์ที่ผมส่งพิมพ์ไปในไลน์นะครับนั่นคือที่ไลฟ์อยู่ so it's private orมัน private หรือว่าอะไรเพราะว่าพวกอันนั้นเขาก็พวก604ครับมัน private หรือเปล่าผมไม่รู้นะทำให้คุณเข้ากันไม่ได้หรือเปล่าจริงด้วยนะเซตเป็น private ไหมก็โอ้ไม่ก็ไม่น่าเลยต้องห้ามทำเป็น private โอ้ผมดันไปเซตเป็น private นะมันจะเข้าไม่ได้นะครับนี่หน้าครับไม่มีคนไปดูที่อันนั้นครับมันเป็น private นี่จะเป็นวันที่ห้อง5ได้โอเคมาเดี๋ยวลืมเรื่องของเรานะครับif you plan to work in the laboratory every day, okay, you may have to you may have to use the Celsius degree and if you plan to work as engineer, okay, all right, yeah, you may also have to face with the อันนี้โอ้ดันไปเซตเป็น privateนะครับน่าจะเข้าได้นะครับอันนั้นไม่เซตเป็น private นะครับ Yeah, if you plan to work as engineer in a factory, like many students of mine, in the factory, they also use the degree of Celsius. Okay, the Celsius degree, and yeah, you can see that Celsius degree is used for a lot of application. Now, but in some countries, like in the United States, we don't use this unit. It's called, we would rather use Fahrenheit, okay, in English-speaking countries, except for United States too, okay, they use Fahrenheit, okay. The Fahrenheit is the synonym from Daniel Fahrenheit. I think he is Polish. Fahrenheit scale is still the most frequently used temperature unit in the United States. and has the freezing point. Okay, the freezing point of water at 32 degrees of Fahrenheit and boiling point at 212. Okay, which is 180 degrees as difference. Okay, and what else? Yeah, if you look at the scale or both scales on the same thermometer, you will see that the boiling point is at 100 degrees at the Celsius side, and you will get 100 or 212. Okay, on the Fahrenheit side, you get the freezing point 0 degree. On the Celsius side, you get 32 degrees of Fahrenheit on the Fahrenheit side. And the human body, the normal temperature for the human body is 37 degrees on Celsius scale and 98.6 degrees on the Fahrenheit scale. Okay, and the room temperature is considered to be 20 degrees of Celsius and 68 degrees on the Fahrenheit scale. Okay, but it's not easy to find 20 degrees of Celsius outside in Thailand. Okay, I don't know why they say it's room temperature. Maybe it's room temperature if you turn on the air conditioner heavily. Okay, yeah, but those two scales are not the only scale that is used around the world. Okay, in daily life, okay, both scales would be sufficient, but if you work in a special area in physics or in many applications in chemistry too, you may have to consider the next temperature unit, which is this one. Okay, how does the temperature how does this temperature unit emerge? Okay, they just scientists have many scientists have a chance to do the experiment about the phases, okay, the states, whether it's liquid, solid, or gas, of many things, and they may have a chance to see the behavior of several kinds of gases. For example, this one, in if they control the volume of the gas to be constant, okay, to keep the volume of the gas constant, and if they let the temperature be higher, what they could observe is the increasing amount of the pressure too. Okay, there is an increasing pressure too. Okay, in yeah, they have tried they have done this experiment for many things, many types of gases. For example, the red one is the first experiment for the first gas. The blue one is the same experiment. When we increase the temperature, we get higher pressure too. In the last one, okay, they use 3 different types of gases, and yeah, beyond the temperature by the water freezing, the water freezing points, they expect that if they plot everything onto the appropriate scale, they observe that all these experiment tends to bring you to the same point. Okay, when the same point where we cannot find any lower temperature possible. Okay, and we will not find any lower possible temperature anymore. And this is the same point for every gas. Okay, and yeah, they found that the heating point here on the x-axis, on the temperature axis, is equal to minus 273.15 degrees of Celsius. Okay, So when we know that when they know that 233 degrees of Celsius is no longer appropriate, is no longer convenient for every people to use, they just build up a new temperature scale, okay, but the pitch or the resolution will be the same as the Celsius scale, okay, because that the scale that the most people use it. All right, yeah, and here is the reason why it comes to this scale. Okay, this scale is was in part discovered by this person, and it's called Kelvin scale. Okay, but Kelvin is not like Celsius or Fahrenheit. Kelvin is the surname of this position. Okay, it's not the name that he was born. He was get why he was born. Okay, his actual name is William Thomson, but as if you have done something good to the society, to the community, you will get the special rank. Okay, like imagine that if you watch the soccer or the football in soccer in American or football in other parts of countries, in other part of the world, we would say football as the soccer, right? But in the United States, you have to say soccer. Otherwise, if you say football, it's gonna be the American football, yeah, NFL and so on, right? And yeah, but imagine that if you are the trainer of the soccer team like Manchester United, but I'm not the friend of Manchester United, okay? And you know that there is a person who is the trainer or the coach of Manchester United, and he was born like a normal people, and when he has done something good to the squad, to Manchester United, they got several prizes, new fashionable leagues and so on, right? And he has got the rank which is called Sir, right? SIR. Yeah, and the typical British system, they have also the rank like Baron Kelvin, and William Thomson was the first person who got this special rank. Okay, and the temperature scale just follow his name. Okay, maybe he got the rank due to his contribution, his work in science or in physics, like that. Okay,นะครับประเทศไทยผมไม่รู้นะถ้าคุณเป็นนักฟิสิกส์ไปเรื่อยๆคุณคิดค้นพบอะไรคุณอาจจะได้รับตำแหน่งยศอะไรก็ได้นะหรืออาจจะขอได้นะครับอาจจะได้รับอะไรนะเครื่องราชอิสริยาภรณ์อะไรอย่างเงี้ยนะคล้ายๆกันนะครับเพราะว่าไทยก็ไปใช้มีลักษณะสังคมอย่างเงี้ยคล้ายๆกับประเทศอังกฤษมาครับ All right, Kelvin is not the actual surname of any person, but it's the surname of this position, of this rank. Okay, we have to deal with Kelvin scale because it's the temperature that is commonly used in science. Okay, if you want to work in laboratory, you cannot avoid to work in to use the Kelvin. Okay, especially in the faculty of science. Okay, for us in engineering, we would not often use the Kelvin scale. Okay, I have never heard the Kelvin scale in engineering. Okay, except that you work in faculty of science, you fall in love with chemistry, you fall in love with physics. If you want to work there in the university with this stuff, okay, you have to deal with Kelvin scale. Okay, it's like if you live in the United States, you are gonna say your height in terms of foot or feet, right? 6 foot, 6 feet, 3 foot, 6 feet, something like that. Okay, and you say you will say your weight in pound rather than kilogram. All right, yeah, that's the thing. And you would say the length in inch or foot or something like that. Yeah, Kelvin scale is special for the people in laboratory in science, and this temperature scale is quite unique because it's defined to have Kelvin for any substance in the space. Okay, the scientists believe that you cannot get minus or negative infinity Celsius or minus infinity Kelvin. Okay, it's impossible. Okay, it's not on the real line like mathematics. In physics, you have to rely on the truth. Okay, they found that 0 Kelvin or minus 273.15 is the lowest possible temperature of anything in the space. Okay, you cannot get the temperature less than this. Okay, and that's the thing that we have to rely on. And yeah, so because of this reason, they would say that Kelvin scale is the absolute scale for the temperature. And what is the reason why they say absolute? Because the 0 value on the Kelvin scale is the lowest temperature that we could have for any stuff. Okay, what is the reason why they say is the absolute the absolute 0 temperature? Because Baron Kelvin has found that when we are at 0 Kelvin, the molecules stop moving. Okay, they don't move at all. When they don't move, there will be no kinetic energy. You know kinetic energy, right? The energy due to the movement of any particle, and it can be found from the expression that you may get used to, right? It's 1/2 mv squared, right? Yeah, at that temperature you would get 0 motion for anything. So in that situation, there will be no kinetic at all. Okay, kinetic energy at all. Yeah, so that's why they say it's absolute 0 and absolute scale, temperature scale. Absolute 0 is the temperature at which everything, including air, freezes solid. Okay, if someday, if our body can sustain or stay in that environment minus 273.15 degrees of Celsius, if human can stay like that, you will see that the air will get the solid phase. Okay, there will be no no gas form of the air anymore. And I don't know, in that situation, how could we breathe then? Yeah, because when the molecules or the atom of the air don't move, okay, there will be no energy. Then when there is no energy, the matter is gonna stay in solid phase. Okay, very low internal energy. So unlike temperature scale, Kelvin scale is an absolute scale. Okay, the other scale like Celsius, Fahrenheit, and you know that there is an additional temperature scale. What is that? The one that I didn't say in this lecture. There is also another temperature scale. Have you ever heard that? Maybe during your time in Mathematics 3, Mathematics 4, Mathematics 5, you may have ever heard that temperature scale, but it's not addressed, it's not said in this lecture notes, in this SCI33205. What is that temperature scale? คุณคิดว่าหน่วยพลังงานหน่วยอุณหภูมิอะไรนะที่มันยังมีอยู่แต่ว่าเราไม่ได้พูดกันเลยนะเนี่ยคุณคิดว่าหน่วยพลังงานอุณหภูมิหน่วยอะไรครับที่ยังไม่ถูกกล่าวถึงเลยและในนี้ก็จะไม่มีกล่าวถึงด้วยมีไปแล้วคือเซลเซียสมีฟาเรนไฮต์มีเคลวินมีอีกอันหนึ่งอะไรครับเคยได้ยินไหมเปิดไมค์ตอบได้นะเชิญเลยครับหรือว่าพิมพ์มาก็ได้นะครับมีใครตอบได้ไหมครับมีไหมเอ่ย ที่ซูมเป็นไงบ้างซูมเหลือ2 คนเหมือนเดิมครับ alright เข้ามาพิมพ์ชื่อแล้วก็หนีกันไปแล้วนะครับแล้วพี่พลครับมันหลุดไปเมื่อกี้นะครับแต่ว่าสั่งอัดแล้วครับก็น่าจะอยู่ในนั้นนะครับมีอีกหน่วยหนึ่งของอุณหภูมิไม่ใช่แบบว่าสอนไปพาคุณไปโลกแคบๆอย่างนี้ไม่ได้บอกให้มันรู้กว้างๆทั้งหมดเดี๋ยวจะหาว่าผมแบบเรียกว่าไงรู้ไม่กว้างแล้วก็เอามาบอกคุณครับผมก็ต้องบอกคุณทั้งหมดนอกเหนือไปจากนี้มันยังมีหน่วยอุณหภูมิอีกอันหนึ่งเรียกว่าอะไรมีใครตอบได้ไหมครับที่ YouTube นะครับมี กฎชวงวัดนะอยู่นะครับแล้วก็ละวิพลอยู่นะครับที่ YouTube มีเหมือนเดิมนะครับมีนนทกรกับปณทัศน์นะอยู่2 คนนะครับคิดว่ามีอะไรนะที่อาจารย์ยังไม่ได้พูดแต่จริงๆมันมีนะผมก็ไม่เคยเห็นเขาใช้กันหรอกนะครับแต่ว่าเรียนมาเนี่ยมีอยู่เคยได้ยินอยู่สมัยม.เหมือนคุณนี่แหละหน่วยอะไรครับอีกอันหนึ่งหน่วยอะไรเอ่ย What is the next What is another temperature unit that was not discussed yet in this lecture Another temperature unit is Romer okay you know Romer รู้จักอุณหภูมิหน่วย Romer ไหมโอเคนั่นแหละนะครับ Romer ไปศึกษาเองนะครับกด Romer ROMER ในอินเทอร์เน็ตมันก็เป็นหน่วยอุณหภูมิอีกอันหนึ่งนะครับเอาละในที่นี้เอาเท่านี้นะเพราะว่าแค่นี้ก็สอนหมดแล้วนะครับ Alright yeah Romer is another temperature unit yeah here we have the volume of gas in the flask and หลอดทดลองเนี่ยครับ is kept constant by raising and lowering the reservoir B okay we can lift it up and lower it down make it lower to keep the mercury level in column A constant okay yeah นะครับวิธีทำให้ปริมาตรแก๊สมันเท่ามันคงที่นะครับก็คือว่าเอาไอ้เนื้อเทาเนี่ยนะครับน้ำสีเทามันซึ่งอาจจะเป็นประหลอดก็ได้นะครับพยายามให้มันอยู่ในเส้นเดียวกันให้มันอยู่0ตลอดเนี้ยตรงนี้เรียกว่า0สมมติคุณเพิ่มลดอุณหภูมิแก๊สมันจะขยายตัวยังไงก็ตามนะครับคุณพยายามถ้าแก๊สมันขยายตัวคุณต้องเอาอะไรดีเอาขึ้นครับเอาขึ้นนะเพื่อว่าให้แก๊สมันชี้ที่0ให้น้ำระดับน้ำสีเทาชี้ที่0เหมือนเดิมนะเพราะตรงนี้มันดันมากเราก็ต้องยกนี้ขึ้นให้มันดันสูงขึ้นไปด้วยหรือว่าเอาลงนะผมว่าเอาลงนะใช่ป่ะน่าจะเอาลงสิถ้าเอาลงปุ๊บมันก็จะดันนะพอคุณให้พลังงานครับแรงดันมันตรงนี้มันสูงนะเราก็ต้องเอาลงครับพอคุณหยุดให้พลังงานไม่ให้ความร้อนมันตรงนี้พลังงานจะต่ำความดันก็จะต่ำด้วยใช่ไหมเราก็ต้องยกขึ้นเพื่อให้ตัวระดับน้ำมันชี้ที่สูงตลอดเวลา okay this is another constant volume gas thermometer okay it's not the thermometer like this okay the thermometer that use the liquid property expansion is the thermometer that we use you may find in hospital or in any health center right even in COVID or pandemic situation you have to see the thermometer right and yeah with this principle the actual constant volume gas thermometer can be found in a realistic situation like this okay and here is the place that we keep the air okay so that we can observe the temperature all right here is what we have already discussed about the absolute zero let's talk about the temperature scale that can happen that exists in nature you know that the lowest temperature of anything could be 0, right? But what they found is something very, very close to 0, which is 10 raised to negative 10. And let's consider somehow like 2 Kelvin. We have helium. Helium is usually a gas, right? It's an inert gas. And at this situation at 2 Kelvin, 2 degrees of Kelvin, the helium changes its phase from gas to liquid already at this level. All right, and if you go further at around 20 Kelvin, the hydrogen, you know, hydrogen, right? H2, usually H2 or hydrogen is a gas, right? And it has only gas phase, but at this position, at this temperature, the hydrogen changes its phase from the gas to be liquid. Okay, let's consider another type of gas, which is nitrogen. Nitrogen will be in liquid form at somehow like 70 degrees of Fahrenheit of Kelvin, and of course for us it's 273.15, right? The water changes its phase from the liquid to the solid one. This is the freezing point. And you know, copper, right? Copper is used as the conductor, right? In many other stuff like device for eating and so on, right? Cuisine stuff and so on. Copper is used for that application. But if you are at 1000 Kelvin, for instance, it's around 700 blah 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 degrees of Celsius. Okay, 700 Celsius degrees of Celsius. That's the melting point of copper. Copper will change its metal phase to liquid phase. All right, but if you are interested more, okay, above 700 Kelvin, we would have here around 6,000, 5,000, 6,000 Kelvin, which is again around 5,000 or 6,000 degrees of Celsius. You are at the surface of the sun, okay, because it's very, very hot, 6,000. I think everything is going to be burned at that position because คุณรู้ใช่ไหมครับว่าขออภัยนะไม่ทราบว่าคุณศาสนาอะไรนะแต่ว่าเท่าที่ผมดูข่าวนะครับเตาเผาวัดนะครับเตาเผาวัดเนี่ยคุณรู้ไหมเขาใช้อุณหภูมิเผาเท่าไหร่ครับมีโควิดคนเสียชีวิตเยอะเขาใช้อุณหภูมิเผาเท่าไหร่คุณทราบฮัลโหลทุกคนอยู่ไหมครับรู้ไหมเอ่ยว่าเผาศพโควิดวัดบางวัดนะวัดที่เขาแบบสนใจสภาพสิ่งแวดล้อมเขาเผาศพที่อุณหภูมิเท่าไหร่ทำไมว่าเผาแบบสนใจสิ่งแวดล้อมก็คือเผาแบบไม่ให้มีเขม่าไม่ให้มีควันแบบให้ออกมาใสกิ๊บเลยครับโดยเฉพาะวัดที่อยู่ในกรุงเทพมหานครนะเพราะว่าเผาเป็นดำปืดๆแล้วมันไม่ได้นะเพราะมันไปตกใส่เสื้อผ้าคนตากคนใช้ชีวิตอยู่อากาศหายใจนะครับในสิ่งบริเวณรอบๆดังนั้นวัดที่เผาศพก็จะต้องเผาแบบไม่ให้มีเขม่าเลยครับคุณรู้ไหมเขาเผาที่อุณหภูมิเท่าไหร่ทราบไหมครับมีใครเปิดไมค์ตอบได้ไหมพิมพ์ใครอยู่ YouTube พิมพ์ก็ได้นะเห็นไหมเขาเผาที่อุณหภูมิประมาณ 1,000 องศาโอเคไหมซึ่งอันนั้นเป็นอุณหภูมิที่สูงมากเลยนะนั่นคือหลอมเหล็กให้แบบละลายได้เลยครับเพื่อไม่ให้มีเขม่านะครับให้ควันออกจากปล่องควันตรงเมนนะครับใสกริบเลยเขาต้องเผาที่อุณหภูมิ 1,000 ครับแล้วค่าดูแลใช้จ่ายสูงมากนะครับโดยเฉพาะอุปกรณ์ที่เตาเผาครับตัวปูนของตัวเมนเองก็แตกร้าวนะครับโอเคมากแล้วคุณนึกดูนะครับที่ผิวของดวงอาทิตย์เนี่ย surface of the sun we are at 5,000 6,000 degree of Celsius or degree of Kelvin. There is no difference at all when we are talking about several thousand of degrees of temperature. All right. Yeah, you know that it's extremely high, much higher than the temperature that we use to burn the body of people from the pandemic situation. All right. And you may ask me, how could the physicists or the scientists say the surface of the sun has a temperature of 5,000 or 6,000 degrees of Kelvin? You may ask me the reason. คุณทราบไหมว่าทำไมนักฟิสิกส์หรือว่านักวิทยาศาสตร์บอกว่าที่ผิวของดวงอาทิตย์มันประมาณ 5,000-6,000 องศามั่วหรือเปล่านั่งมโนหรือว่าเขานั่งยานอวกาศไปวัดอุณหภูมิเอาเทอร์โมมิเตอร์ไปจิ้มอยู่ตรงนั้นหรือเปล่าหรือว่าไง What is the reason behind that
ไม่ใช่แบบว่าเรียนแล้วก็สอบจบอะไรนะทำดูในเอกสารประกอบการเรียนของอาจารย์ไม่ต้องทำอะไรมากวิธีทำมันก็ชัดเจนตรงๆก็สอบจบผ่านวิชานี้มันไม่ใช่อย่างแค่นั้นนะคุณต้องอยู่ในตามสภาพความเป็นจริงนะผมไม่ได้สอนแมทนะครับเห็นไหมแมทมันไม่ค่อยเกี่ยวข้องกับโลกความเป็นจริงแต่ว่าฟิสิกส์มันคือวิทยาศาสตร์มันคือแบบมนุษย์พยายามทราบสิ่งที่มีอยู่รอบตัวนะครับในธรรมชาตินะเห็นไหม so what is the reason why scientists or physicists could say the surface of the sun is at the temperature of 5,000 to 6,000 by which sense? Because they use the light, okay, emitted from the sun, okay, to predict the temperature. Okay, the scientists use the photon or the light spectrum to determine the temperature of anything, because we would not have enough money to build up the spacecraft to reach the surface of the sun. Okay, what we could do is to build up a very giant, okay, the big telescope, okay, to observe anything around the earth or in the deep space. Okay, and in solar corona, in some area in the space, they have temperature around 1 million Kelvin. Okay, โอ้ไม่ต้องพูดถึงครับถ้าเป็นล้านนี่มนุษย์ไปไม่หลงเหลือครับเป็นเผาเกลี้ยงหมดครับโอเคไหม and inside the sun, okay, inside the sun, the interior of the sun, we have 10 million degrees of Kelvin. Okay, it's very extremely hot. Okay, and hydrogen bomb, okay, which is a kind of process that could happen in deep space. Actually, it's kind of nuclear fusion effect, right? Nuclear fusion process, right? Yeah, the temperature of this process is 200 million degrees of Celsius. You can see that this is impossible for the scientists, which is also as same as they are also human. They could observe this. Okay, we could not build up any thermometer that can support 100 million degrees of Kelvin. Okay, the scientists just used the light spectrum that could be observed from the telescope on any spatial device. Okay, and they convert the color of that spectrum to the temperature somehow. Okay, if you want to see the detail, you just study in the Faculty of Science, or you just browse it from internet. You don't have to attend the Faculty of Science. You can go ahead with your future. If you want to become a doctor, just go ahead with doctor. And if you want to see how the scientists interpret the light spectrum as the temperature, you just find a special reading or book about that. Okay, I'm not from the Faculty of Science. I don't know the method how the physicists or the scientists convert the light spectrum to be the temperature scale. All right, let's move to the next thing. If we compare all those three
temperature scale, Celsius, Fahrenheit, and Kelvin, you will see that freezing point of water is 0, and on Fahrenheit it's 32, and on Kelvin it's 273.15. The steaming point or the vaporizing point of the water is 100 degrees of Celsius, 212 degrees of Fahrenheit, 233.15 degrees of Kelvin. Okay, and yeah, normal temperature is 35, right? In Fahrenheit, we would say 98.6 degree of Fahrenheit. Okay, if you wanna do the PhD, if you want to study the doctoral degree in the United States, okay, the people use Fahrenheit scale. You have to remember this number 98.6, okay, which is your body, your normal temperature for the normal temperature for your body. Okay, and on the Kelvin scale is going to be 310.15. All right, and anything else? Oxygen will be in liquid form in 90 degrees of Kelvin, minus 195 degrees of Celsius, and minus 298 degrees of Fahrenheit. And carbon dioxide changes its phase from gas to be solid at 195 degrees of Kelvin and negative 78 degrees of Celsius and negative 109 degrees of Fahrenheit. Okay, and yeah, these two points are already discussed. Okay, now we arrive at the main the main interest for us is the conversion of temperature scale. As you know, we have 3 temperature scale before, right? Celsius, Fahrenheit, and Kelvin. If you want to convert the temperature from Celsius to Fahrenheit, you have this formula. Temperature in Fahrenheit is 9/5 of temperature in Celsius plus 32. If you have Fahrenheit and you scale, you want to convert any temperature to Celsius, you have to use this formula. Its temperature in Celsius is equal to 5/9 of the difference between temperature in Fahrenheit minus 32, right? Celsius to Kelvin is quite straightforward. You just add 273.15. If you want to get Kelvin from Celsius, you just deduce or subtract the temperature in Kelvin by 273.15. All right, and Fahrenheit to Kelvin is equal to 5/9. Okay, 5/9 of temperature in Fahrenheit minus 32, and this is the value you get in Celsius scale, right? But if you want to convert to Kelvin, you have to add 273.15 according to this formula. Okay, you combine these two formula together, you get this expression. And if you want to get Kelvin from the Fahrenheit, you have to convert first the Fahrenheit to Celsius like this, okay, and you convert the Celsius to Kelvin by using this formula. Okay, you combine these two formulas together. Okay, substitute this one into this one, you get the Kelvin to Fahrenheit. Okay, that's the whole theory. Okay, you can choose any way the combination. It depends on the input and output, what you want to get at the outcome. And yeah, the way to get the temperature difference is like this. Okay, the temperature difference between Fahrenheit and temperature difference in Celsius is somehow like this. Let's consider room temperature. If we define as 25, okay, unlike the former one, they say 20 degrees of Celsius as room temperature. Okay, is in the milder situation, the situation that we could live well, it's 25 degrees of Celsius, and yeah, this could be possible if you turn on your air conditioner in Thailand. Yeah, the find the room temperature in degrees of Fahrenheit, find the room temperature in Kelvin. Okay,
yeah 25 right มีใครจะทำไหมไม่มีนะครับถ้าปกติห้องจริงผมจะเรียกให้มาทำนะตรงนี้ทุกคนทำได้ไม่ยากนะครับน่าจะเป็นกันตั้งแต่ชั้นม.ต้นแล้วด้วยซ้ำนะครับ Okay anyway it's my task to show you how to do that right we want to get room temperature in Fahrenheit scale and we have to see it's 9/5 right 9/5 temperature in Celsius right in I think it's plus 32 right yeah 9/5 9/5 plus 32 okay and you leave it the 25 right 9/5 of 25 plus 32 is equal to 45 plus 32 right it's gonna be 77 degrees of Fahrenheit. All right, that's the first equation. Okay, the first solution for this problem. And the temperature in Kelvin, right? Temperature in Kelvin is quite easy. You have TK, and if you have TC, you have to add it by 273.15. Okay, in this case, we get 25 plus 273 จริงๆคุณเอาแค่273ใช้ก็ได้นะไม่ต้องเอาบ้าจี้เหมือนผมครับ273.15ครับ so it's going to be 298.35 degrees of Kelvin. All right, and that's it for this example. All right, yeah, we arrive at next example, but this will involve some special vocabularies. The temperature gradient between the skin and the air is regulated by the cutaneous blood flow. Sorry. Okay. ก็คือเขาบอกว่าการเปลี่ยนแปลงอุณหภูมินะครับระหว่างผิวหนังและอากาศภายนอกนะครับของคนนะครับถูกควบคุมโดยเส้นเลือดฝอยที่ผิวเราสิมันเรียนอะไรนะเรียนฟิสิกส์จะไปเกี่ยวข้องกับชีวะได้ด้วยนะครับโอเคไหมครับประมาณนั้นเส้นเลือดฝอยนะครับเป็นสิ่งที่อุปกรณ์คือร่างกายมนุษย์เนี่ยโหมันสุดยอดมากนะครับมันสามารถปรับอุณหภูมิตัวเราโดยการปล่อยเลือดไหลไปตามเส้นเลือดฝอยเจ๋งไหมล่ะเยี่ยมไหมครับif the cutaneous blood vessels are constricted the skin temperature and the temperature of the event will be about the same okay ก็คือสมมติคุณไปที่หนาวๆครับถ้าเส้นเลือดฝอยมันหดตัวไม่ยอมให้เลือดมันไหลนะครับไม่ยอมให้เลือดไหลตามผิวเพราะไม่มีการเอาของอุ่นไปวิ่งรอบตัวคุณนะครับแขนของเราจะเย็นมากเห็นไหมแขนของเราเนี่ยจะเท่ากับอุณหภูมิข้างนอกเลยนะครับก็คือเริ่มมีปัญหาแล้วนะครับเส้นเลือดฝอยหดตัวนะครับไม่ยอมให้เลือดไหลนะครับเลือดไหลก็คือรักษาอุณหภูมิร่างกายนะครับ when the vessels are dilated more blood is brought to the surface โอเคเมื่อเส้นเลือดมันขยายปุ๊บเลือดมันก็จะวิ่งไปทั่วตามผิวหนังเราตัวเราก็จะเป็นไงครับไม่ใช่เลือดฝาดเลือดแดงแก้มแดงนะหมายถึงว่าตัวเราก็จะอุ่นขึ้นอุณหภูมิสูงขึ้นโอเคไหมนั่นคืออัจฉริยะของมนุษย์นะคือเรียนวิศวะเนี่ยนะครับณปัจจุบันนี้นะคุณจะคิดอัลกอริทึมอะไรก็ได้นะให้มันฉลาดเท่าระบบปฏิบัติการของร่างกายมนุษย์เนี่ยที่มันสู้เชื้อโรคได้เนี่ยคือว่าถือว่าเก่งมากเลยนะครับมีระบบนิวรอนคือแบบมีส่วนควบคุมได้สุดยอดมากร่างกายมนุษย์นะครับณปัจจุบันวิศวกรรมยังไปไม่ถึงนะครับผมพูดได้ประมาณนี้นะยังฉลาดไม่สู้ร่างกายมนุษย์ครับเนี่ยแค่ระบบปรับอุณหภูมิร่างกายตัวเองโอ้โหยังอัตโนมัติได้ขนาดนี้นะครับดังนั้นรักษาสุขภาพร่างกายคุณให้ดีๆนะครับเห็นไหมมันเป็นระบบที่ชาญฉลาดมากแล้วนะครับอย่าให้พังเสียหายครับ เก็บไว้ใช้เอาไว้สร้างให้คุณเจริญงอกงามไปข้างหน้าในอนาคตนะครับ Suppose during duration of the skin warms 72 degrees of Fahrenheit to 84นะเริ่มมีการกระจายเลือดเข้าไปในร่างกายแล้วนะครับทำให้อุณหภูมิคุณสูงขึ้นจาก72 ฟาเรนไฮต์ถึง84 ฟาเรนไฮต์คือมันพูดรู้เรื่องอ่ะถ้าคุณอยู่ในอเมริกาอยู่ในสเตทอ่ะเข้าใจไหมมันรู้เรื่องอ่ะแต่เรามันไม่ได้อยู่อเมริกาคุณพูดมาฟาเรนไฮต์แล้วใครคนก็จะงงอ่ะโอเคไหมครับหรือว่าคุณไปฉีดวัคซีนแล้วคุณบอกอุณหภูมิคุณอยู่ในหน่วยเคลวินอย่างเงี้ยคุณหมอคุณพยาบาลคุณแพทย์นี่งงตึงนะครับโอเคไหมเขาไม่ค่อยใช้เคลวินกันโอเคไหมครับเขาใช้แต่ degree of Celsius นะครับหรือคุณจะไปพูดฟาเรนไฮต์กับคุณหมอที่ประเทศไทยนี่ก็คุณพยาบาลหรือคนเจ้าหน้าที่ก็จะงงตึงเหมือนกันดังนั้นเปลี่ยนหน่วยให้เขาเสียก่อนนะครับโอเคไหม so let's consider the first problem convert these temperatures to Celsius and find the difference and convert the temperature to Kelvin again find the difference okay yeah we want to convert the temperature from Fahrenheit scale right to the Celsius scale right in one thing I forgot to mention one thing I forgot to mention the Kelvin scale okay the Kelvin scale doesn't require the small circle at all okay K has no small circle you can see here Fahrenheit has degree Celsius has degree symbol which is small circle but Kelvin doesn't have it doesn't need degrees at all what is the reason behind that because Kelvin scale is the absolute scale okay no other matter substance can reach the negative 273.15 okay so we don't write down the degrees or the small circle anymore for Kelvin scale all right that's the typical way อยากเขียนวงกลมมานะเขียนวงกลมมาเสลอเลยนะครับเขียนมา so the next question is convert the temperature from Fahrenheit to Kelvin so it's not difficult in this case whenever you are able to convert the temperature to Celsius all right so let's consider the next thing when the okay we first consider the temperature at 72 degree oh no degrees of Fahrenheit right and the second one no we'll see it later the second one okay and at the 32 Fahrenheit if you want to convert it to degrees of Celsius okay it's possible you just say TC is equal to it's 5/9 right 5/9 and TF minus 32 right yeah and we have to substitute right now 5/9 and what is that 32 72 minus 32 is going to be 5/9 of 40 okay and you have to multiply this and it's going to be 200/9 okay and we use the calculator 200/9 okay it's equal to 22.22 okay it's around 22.22 degrees of Celsius is that all right I'm not sure hi 72 to 22 72 Fahrenheit to Celsius Yes, it's all right. It's correct. Okay. And what about this temperature in Kelvin? So TK is going to be TC, right? Plus 273.15, and it's going to be 22.22 plus 273.15. I think we are running out of time. 295.37 Kelvin. Okay, and here is degrees of Celsius. And in the second state, at the temperature of 84 Fahrenheit, we can get TC from this expression. 5/9 of TF minus 32, yes, and 5/9, and TF is 84 minus 32. You get 5/9 of 52, right? And it's gonna be 260/9. It's equal to
นะครับแต่เริ่มต้นนะครับอุณหภูมิควร22 องศาซึ่งถือว่าค่อนข้างต่ำนะครับโอเคนะครับ
and 260 is going to be 28. Okay, 28.89 degrees of Celsius. Okay, เพิ่มเยอะโอเคครับจาก22มา28เกือบ29องศานะครับเพิ่มเส้นเลือดปล่อยเลือดเลี้ยงไปตามเส้นเลือดฝอยนะครับร่างกายจัดการ so we're gonna find the third thing. Okay, the delta temperature in what is that, in Celsius and Kelvin, right? TC, delta TC, what is that, right? And delta TK, what is that, right? So what is delta TC? Delta TC is going to be what is that? Oh, I forget to say T Kelvin in this situation. T Kelvin is going to be TC plus 273.15, right? Which is 28.89 plus 273.15, right? And here is going to be 4.9, right? 0 and 1, right? And 9, 301 point 1. Yes, and it's in Kelvin, right? In the second state. Okay, delta TC is going to be 28.89 minus 22.22, right? Yes, 0.22. It's going to be 6.67 and degree of Celsius. And for the delta TK, difference of temperature in Kelvin scale is going to be the same thing actually. So 301.04 minus 295.37, and you would get 7 and 6 and 6 again. Okay, you can see that the difference of temperature, whether in degrees of Celsius or Kelvin, will be the same. 6.67. And now we reach the final example. Normal internal body for human
is 98.6. Find the temperature in degrees of Celsius and in Kelvin. And the first situation first, okay. In the first situation, we have 98.6 degrees of Fahrenheit. And we want to find the temperature in Celsius. TC is, how could we find that? It's 5/9, right? 5/9 of TF minus 32, and you get 5/9 of 98.6 minus 32, and it's going to be 5/9 of 6.6, and 6, okay, 3 times of, oh no, 5, yeah, 6, yeah, 6, 3 times of number 6, and you would get, I think, 37 degrees of Celsius, I think, right? And let me check it again, otherwise you get something wrong, and that's why that will be my mistake. 5/9 times 60, oh, 66.6. It's 37 exactly, yeah. Here, okay, the value in degrees of Celsius, and the temperature in Kelvin is going to be 273.15 plus TC, okay, which is 273.15 plus 37, and it's going to be 310.15 degree of Kelvin, okay, and that's it. Let's consider the second situation. They say when human is relaxing on a couch, okay, if you sit down on a couch, your body is clever, okay, is intelligent. The skin temperature is reduced, okay. They will not let the blood flow around your body, okay, and then your body is going to be cooler, okay, and the cooler amount is 2 degrees Celsius reduction, and yeah, than the internal temperature. And how much lower is the skin temperature in Fahrenheit degrees and in Celsius? Okay, you have the change of temperature by in the second situation, you have the difference of temperature in Celsius by 2, right? By 2 degrees of Celsius, and you want to convert it to Fahrenheit, right? So you have to use this expression, this one, okay? Delta TF is 9/5 of delta TC, okay? Delta TF is 9/5 delta TC. So we use this one. We use that expression. Delta TF is 9/5 delta TZ. So you have difference as number 2, right? So you just multiply it, and it's what is that? It's 19/5, right? 19/5. It's going to be 3.6 degrees of Fahrenheit. All right, and that's it. And if you consider the difference of the temperature in Kelvin scale, delta TK is going to be exactly the same as delta TC, okay, which is 2 degrees of Kelvin. Okay, all right, we complete all of this stuff. We are running out of time, 6 minutes later. โอเคนะครับวันนี้ก็จบเรื่องเกี่ยวกับการเปลี่ยนหน่วยของอุณหภูมินะครับก็เริ่มต้นของวันนี้เหรอครับก็กล่าวเกี่ยวกับเรื่องยูนิตอุณหภูมินะครับที่หน่วยของอุณหภูมินะเริ่มจากเซลเซียสเลยนะครับเห็นไหมเริ่มจาก
under Celsius นะครับก็คือหน่วยเซลเซียสนะครับแล้วก็ว่ากันไปครับใช้ทั่วโลกครับแล้วก็ฟาเรนไฮต์นะครับใช้โดยเฉพาะประเทศสหรัฐอเมริกาแล้วก็ประเทศที่ใช้ภาษาอังกฤษหลักนะครับเช่นพวกอาจจะแอฟริกาใต้ด้วยอะไรอย่างนี้นะครับผมก็ไม่เคยไปนะครับก็พูดถึงสเกลนะครับวัดจากจุดแข็งตัวของน้ำแล้วก็จุดเดือดของน้ำนะครับแล้วก็มาอุณหภูมิที่นักวิทยาศาสตร์ใช้ไม่ใช่แค่ในห้องทดลองนะครับอันนี้มันจะเน้นไปเกี่ยวกับสสารที่อยู่นอกโลกด้วยนะครับเห็นไหมอุณหภูมิแบบสุดขั้วจริงๆนะครับนั่นคือเปลี่ยนสถานะกันสุดๆนะครับนั่นคือเคลวินนะครับก็เป็นยุคใหม่ของหน่วยอุณหภูมินะครับก็มีสูตรในการเคลวินหามาได้จากการที่นักวิทยาศาสตร์วัดแก๊สนะครับแล้วก็คิดว่ามันน่าจะโปรเจกต์ไปยังค่าหนึ่งนะครับนั่นแหละก็ไม่แน่นะคุณอาจจะเป็นนักวิทยาศาสตร์ยุคใหม่นะอาจจะค้นพบสิ่งใหม่ๆนะครับเพราะว่ายังไงผมก็เป็นคนรุ่นเก่าไปแล้วนะหวังได้แต่พลังงานความสามารถคุณนะครับก็สเกลต่างๆของอุณหภูมินะครับที่อยู่ในวิชาฟิสิกส์ในที่เราสามารถมนุษย์สังเกตได้นอกโลกนะครับตั้งแต่ไฮโดรเจนบอมปฏิกิริยานิวเคลียร์ฟิวชันนะครับแล้วก็ภายในเลยนะของดวงอาทิตย์นะครับจะประมาณ10 ล้านอันนี้100 ล้านนะครับปฏิกิริยานิวเคลียร์ฟิวชันแล้วก็ตัววงแหวนโซล่านะครับรอบๆดวงอาทิตย์ก็จะประมาณ1 ล้านครับแล้วก็ที่ผิวโซล่าโคโรนาก็คือวงแหวนของระบบสุริยะนะครับแล้วก็เซอร์เฟซผิวของดวงอาทิตย์ก็จะประมาณสัก 5,000-6,000 นะครับแล้วก็นะครับอันนี้จะเป็นในโลกแล้วนะครับจุดหลอมเหลวของทองแดงแข็งจุดแข็งน้ำอะไรพวกนี้นะครับเป็นในโลกหมดแล้วนะครับแล้วก็อุณหภูมิสเกลต่างๆจะเห็นว่าพิชหรือว่าความถี่ของบาร์ของแถบนะครับบนฟาเรนไฮต์ก็จะแน่นกว่าของพวกเคลวินและก็เซลเซียสนะครับแล้วก็สเกลต่อสเกลนะครับจุดเดียวกันนะครับอุณหภูมิห้องอุณหภูมิร่างกายมนุษย์นะครับก็จะมีนะครับเป็นค่าไปนะครับแล้วเราก็มาถึงสสารพวกแก๊สนะครับเปลี่ยนเป็นของแข็งออกซิเจนเปลี่ยนเป็นของเหลวอะไรอย่างเงี้ยนะครับหรือว่าเก็บอะไรนะวัคซีนไฟเซอร์ก็-70 องศาอะไรอย่างเงี้ยนะครับหรือมาถึงเรื่องการเปลี่ยนแปลงอุณหภูมินะครับจากสเกลหนึ่งไปสเกลหนึ่งก็มีสูตรต่างๆให้ดังนี้นะครับแล้วผมก็พาหาการดูตัวอย่างนะครับ3 ตัวอย่างนะในการเปลี่ยนอุณหภูมิให้ดูนะครับเขียนมาก็ทำให้ตรงนี้แล้วเดี๋ยว convert file ส่งให้นะใครยังไม่ได้เขียนชื่อโปรดเขียนชื่อนะครับso we are gonna finish our lecture right now it's noon okay see you on next Thursday right สวัสดีครับบ๊ายบายครับ no one is gonna be there okay only นนทกรสวัสดีครับบ๊ายบายครับ